Section 5.1, solving systems of linear equations in two variables. How do we solve systems of equations? There are three different ways of doing so. The first method, or the first way, is by graphing, which is the least favorite method, because you actually need a graphing paper to be able to see the solutions, and if the solutions are not like integers, it's kind of hard to find the exact solution. The next one is the one that we use a lot, is called elimination method, and the last method is called substitution. Sometimes substitution is easier than elimination, sometimes elimination is easier. To do that, when I talk about graphing, just recall that straight lines are written in the form y equals mx plus b. B is called the y-intercept, and m is the slope, which is rise over run. Is the slope, rise over run. So if we recall how to graph, let's say someone asks us to graph a straight line such as x plus 2. How do you graph this? I'm just recalling stuff. On the xy plane, I always put the arrows, the origin, label x and y. There are many ways to do this. You can use points, like take x0, y, get the y, y0, get the x. We call them intercepts. Or you can start at the y-intercept, which is 2, and the slope here is 1. It's this number 1, or 1 over 1. So rise over run. So you go up 1, 1 to the right. That's the straight line. And notice, do not just connect the two dots. You must extend it on both sides or both ends, and then use the arrows. So this is how we graph straight lines. And how are we going to apply it in this section? Well, let's say they ask us to solve by graphing. So solve by graphing. Let's look at an example. Say y equals x minus 3 and x plus y equals 7. Okay, so how do we graph something like this? Well, we start by graphing the first one. As we just graphed the earlier one, the y-intercept is -3. 1, 2, and 3. It's here. The slope is 1 over 1. So 1 up, 1 to the right. That's the slope. That gave me the straight line. Now for the second line, we need to solve for y first. So subtract x on both sides. You get y equals -x plus 7. So the y-intercept is 7. So maybe I should extend this line a little bit more up. So we got 1, 2, 3, 4, 5, 6, 7. That's 7. And the slope here is -1, or -1 over 1. This means 1 down, 1 over. So you do it this way and then extend it. So this was the first one, y equals x minus 3. This is the second line, x plus y equals 7. When we are asked to solve something like this, they are asking us, do these two lines intersect? And if so, where do they intersect? Well, they intersect at point, I'm gonna call it A, this point. What are the coordinates of this? Well, if you try to go by the graphing paper, 1, 2, 3, 4, you're gonna find exactly at 5, believe it or not. And the y value is exactly at, let me see, is exactly at 2. So that would be 5, 2. 5, 2. So those are the coordinates of the points. And then you say, wait, what this has to do with the system? Well, when they ask us to solve, they ask us what is the x value and the y value. If you substitute on both of them, it will satisfy the two equations. That's what it means to solve. We need to find the x and y value. If I put them in the first and the second, I'll get the same number on both sides. Well, let's see what we do. Now, to make this to work, I need the x and y values. I found the point of intersection. Why did I find the point of intersection? Because that gives me the x value, which is 5, and that gives me the y value, which is 2. X 5, y 2. So, luckily enough, we were able to find it. And that's why I mentioned this is the least favorable method for almost everybody out there, both teachers and students. Because if the answers are not integers, as you could see here, it's going to be difficult for students to see it, even if you have a graphing paper. So that's why when we give students to solve for a system of equations, we make sure we give them one that the coordinates are integers. The coordinates of the points of intersection. Note, so when they met, as we could see, this would be the solution if the two lines we draw them. What about if you draw these two straight lines and it just happened they are parallel to each other? This means they would never meet. There's no point of intersection. It means no solution. It means no solution. And in some cases, you graph a straight line. Okay, that's the first line. And then you graph the second line, and guess what? It coincides with this. This means at every single point they met, it's a solution. So that means this has infinite number of solutions. Infinite number of solutions. Infinite number of solutions. What about if we try to solve 2x plus y equals -1 and y minus x equals 5? Always, I remind the students to pause the videos, try it on your own. This might take you about 5 minutes, that's fine, and see how far you can go with this. Now, when we say solve this, you can use any method you like. But on a test, if they say solve by graphing, you must use graphing because they are trying to test you if you can do it by graphing or not. So I'm going to still do this by graphing just for practice so you guys can see it. So if I look at the first line, I'm going to graph this first straight line. Subtract 2x on both sides. I got y equals -2x minus 1. And for the second line, I'm going to rewrite it again, adding x to both sides. I get this. So I have two lines to graph. Let's try to graph them. X, y, 0, give yourself enough space. The first line has y-intercept -1. So it's a -1 here. The slope here, -2/1. So 2 units down, 1 to the right. So that's the first line, or straight line. The next one, the y-intercept 5. 1, 2, 3, 4, 5. 1/1, so 1 to the right. So that gives us a solution, or the point of intersection here. Call it A. Now I'm assuming I have a graphing paper, so it's going to be -1, -2. That's at -2. And then if you look at it on the graph paper as I'm doing here, it's 1, 2, it's exactly at 3. So A has coordinates -2, 3. And in return, this tells me that x is -2 and y is 3. These are the solutions, or this is the solution for this. Elimination method. Elimination, the reason we call it elimination method because we eliminate one of the variables, either x or y, and that will help me to solve for the other variable that I did not eliminate. So let's try to solve something like this. 4x minus y is 1. 2x plus y is 5. If you look at these two equations and add them up, just add them up, notice how the y's cancel. So the y's get eliminated. So that gives me 6x equals 6. So x is 1. I got x equals 1. Now where do I substitute this? I can go back, substitute either in the first or second and get the corresponding y value. And it should work in either one of them. I would substitute in the second one. X is 1. 2 times 1, 2 plus y is 5. So y is 3. So that gives me x1, y3. So it's much easier. I don't have to graph straight lines. The answer I got is just x1, y3. That's the solution. When we get a solution to any system, like one solution as you can see, then the system is called, so the system is called independent. If we solve a system of equations and we got a solution, one solution, system is called independent. Let's look at another example. Solve by elimination. 3x minus 2y is equals to 4. X plus y equals 3. So how do we do this by elimination? First thing, if I add them up, neither x nor y cancel each other. Okay, neither x nor y cancel each other. But I want to eliminate, it's easier I think if we eliminate the y's. It doesn't really matter, but if I have a 2 here, just there, then I add them, that will cancel the y's. But I can't just put 2 there. So I'm going to multiply the second equation by 2. You have to multiply the entire equation to balance it. So we keep the first equation the same as 3x minus 2y equals 4. The second equation is 2x plus 2y equals 6. And now we can add the two equations up. These get cancelled. 5x is 10. X is 2. And I got the x value. I'm going to substitute this back into the second equation right there. X plus y is 3. I want to find its corresponding y value. So 2 plus y is 3. Y in this case is 1. So that gives us a solution, one solution, 2, 1. So keep in mind that means the system is independent. System is independent. Let's look at another example. In this example, I'm going to throw some fractions. 1/2 x minus 1/4 y equals 1. 2x minus y equals 3. How do we solve such equation or system of equations? What makes this difficult is having fractions involved. So I'm not going to multiply the second equation by like -1/4 or something. The easiest way to do this is to, what I say, clean up the fractions. Clean means get rid of the fractions. And the easiest way to get rid of fractions, this is over 1, 4, and 2. So 1, 4, 1, 4, 2. The LCD for them is 4. So multiply this entire equation by 4. When I multiply the first one by 4, like 4 here and 4 here, 4 here, that will give me 2x minus 1y equals 4. The second equation stays the same. Now let's say I want to eliminate the y's. So I'm going to multiply by -1 to make this +1 in the middle. So the first equation stays the same. Second equation becomes -2x plus y equals -3. Add them up. These cancel, these cancel. I got a 0. That's I got on the left side. And the right side I got 1. Wait, 0 equals 1. That's impossible, right? So this means there is no solution to this equation, to this system. There is no solution. And in this case, if there's no solution, the system, we call it the system, is inconsistent. Inconsistent. Notice something within my solutions. When I wrote the next step, I multiplied the first equation by 4. What happened to the second equation? Did I modify it? No, I did not modify the second equation at all. And yet, I copied it down. So this way I keep things organized within the braces. No, those things on the left side called braces. The same thing happened on the next step. I did not modify the first equation, I multiplied only the second equation by -1. So then what I did, when I multiplied by -1, I kept the first equation the same. So this way the work is gonna stay organized. Next one, I'm going to solve this. 2x equals 10 minus 5y and 1/5 x plus 1/2 y equals 1. So I'm gonna solve this system of equations. So how do I solve this? Again, I see fractions in the second equation. So the LCD to 1, 2, and 5 is 10. Multiply by 10. Keep the first equation the same, or what do you think? Oh no, look how it's not organized as x, y, and numbers. So I'm gonna add 5y to both sides to the first equation to make it x, y equals number. I added 5y to both sides of the first equation. Second equation, when you multiply by 10 here, by 10, so that gives me 2x plus 5y equals 10. Okay, so let's say I want to multiply this by -1 to eliminate the x's or the y's. What do we get? The first equation stays the same. Copy it down. This is -2x minus 5y equals -10. Cancels, so 0 equals 0. What does that mean, 0 equals 0? That tells me the system has infinite number of solutions. Infinite number of solutions. So for any x, y values you substitute them in, is going to satisfy the system. In this case, we say the system is dependent. The system is dependent. We can summarize those cases here. We say a system of equations with number 1, exactly one solution is called independent. It's called independent. If it has no solution, it's called inconsistent. If it has infinite number of solutions, infinite number of solutions is called dependent. Is called dependent. Now, why are we learning system of equations to solve system of equations? One applications to this. Let's say we have two DVDs and 3 CDs. Cost us $78. Let's say 1 DVD and 4 CDs cost $74. What is the cost? What is the cost of a DVD? So how do you find the cost of a DVD? How do we set that up? Some students must sit and try like guess and check. If the answer is like an integer, you're okay, but if it's not like decimals, it would be hard to guess. So they ask them, what's the cost of a DVD? So they talk about two things, DVDs and CDs. So let's say, what is the cost? So let X be the cost of a DVD and Y be the cost of a CD. So they said 2 DVDs and 3 CDs. So 2 DVDs, 2X, and 3 CDs cost $78. One DVD, 4 CDs cost $74. So notice I got a system of equations. Now, what do we need to do here? What they said, what is the cost of a DVD? So they're asking, what is X? So there are many ways to finish this problem. If you want to get what X is, you eliminate the Y. You want to eliminate the Y. But wait, what can I multiply the top to eliminate it with 4? There's nothing, or unless if you want to use fractions. What about the bottom? Multiply by what to eliminate the Y's? Nothing. So in this case, watch what you do. You look at 3 and 4. The least common multiple of them is 12. So least common LCM for 3 and 4 is 12. That's a nice way to work it out. So this means I want to make sure each one is 12 so that one of them is negative, one positive. So to do that, I need to multiply this by 4, and I'm going to multiply the bottom one by negative 3, because that's how I make it one positive, one negative. So what do we get? 2 times 4 is 8x. 3 times 4 is 12y. 78 times 4 is 312. The next one, negative 3 times x, negative 3x. Negative 3 times 4, minus 12y. 74 times negative 3 is negative 222. These cancel out. So you get 5x equals 312 minus 222 is 90. Then divide both sides by 5. That gives us $18. That's the cost per DVD. That's an application. So what we have done so far, we went through some examples about solving equations using graphs. Then we went over some examples about elimination. We listed down the cases. If we got one solution, what do we call the system? No solution, what we call it? Infinite number of solution, what we call it? And what does it mean graphically? One solution means that two lines will intersect at one point. Parallel lines means no solution. If the two lines coincide with each other, means infinite number of solutions. Now the last thing is the the substitution method. So let's say we are asked to solve a system like this. 2y equals 1 minus 4x and 2x plus y equals 0. So solve this, let's say, by substitution. So how do we solve by substitution? Substitution means you're going to substitute one of the variables from one equation into the other equation. So maybe if you look at it's not easy to solve for the first one, you get fractions if you solve for y or x. But from this equation, if I subtract 2x on both sides, I got y equals negative 2x. Remember, I need to find the value of x and y if they exist, if there is a solution. Okay, so what do we do here? I got y equals negative 2x. I'm going to substitute this into the first equation. Let me rewrite the first equation again. Okay, and we are going to substitute that in there. Instead of y, so 2 times, put negative 2x. This is negative 4x equals 1 minus 4x. Add 4x to both sides. That gives us 0 equals 1. So what does that mean? 0 equals 1 means the system has no solution. No solutions, because 0 will never equal to 1. If you got something doesn't equal itself, a number equal a different number, this tells us the system has no solutions. And if you graph these two equations, you will find that they are parallel. No matter how far you extend both of them on both ends, they will never meet. That's what no solutions mean. They will never intersect at a point. That's what this section is about, how to solve a system of equations. And again, the most important part about system of equations, they help us to solve a lot of word problems. And those word problems, they come from real life applications. So, and we saw one of them here about the DVDs and CDs. They go a lot, there's a lot of applications to them in the financial, like we call them financial applications. There's so many applications to those. Even in the next section, we're going to look at what about if we have three equations, like in three unknowns, x, y, and z, how to solve them. So we're going to see that in the next section.